Hey everyone! Today we're diving into reverse engineering, the powerful technique hackers use to crack software and uncover hidden secrets. Whether it's breaking down programs, analyzing hardware, or unlocking systems, we're going to explore how it all works and what makes it so fascinating. Quick pause before we dive in. If you want to sip coffee like a true hacker, check out the Brute Force mug guaranteed to boost your password cracking skills. Or slap on a not that kind of pen tester sticker for some subtle geek humor. Your support keeps this channel running, so a huge thanks. Now let's get back to the good stuff. Reverse engineering is the process of taking something apart to see how it was built and how it operates. When you interact with any software, be it a game, an operating system, or even malware, you're dealing with machine code, the language that computers speak fluently, but most humans avoid like the plague. But inside that machine code is where all the interesting stuff happens, like the variables controlling your health in a game, or the logic behind a security protocol. The key to reverse engineering is figuring out how this machine code translates to the higher level operations you're interested in. The information you're after, whether it's game variables or system control points, is often hidden in plain sight, stored in random access memory, RAM. The goal is to find these memory addresses and understand how the software behaves. Think of it as digital detective work. Reverse engineering typically falls into two categories: static and dynamic. Static analysis is like inspecting a locked door safe, but you're not seeing it in action. Dynamic analysis, on the other hand, is like watching that door open and close in real time. Both methods are crucial, whether you're trying to understand the security flaws in an application or figure out how a game stores its level data. As with any technical skill, getting good at reverse engineering takes time and practice. There are no shortcuts, but there are ways to accelerate your learning. For starters, proficiency in low-level programming languages like C or C++ is a huge advantage. These languages force you to deal directly with memory addresses and pointers, which are central to reverse engineering. And if you haven't already, get comfortable with assembly code. You don't need to love it, but you do need to understand it. Assembly is where the rubber meets the road in reverse engineering. Many start their journey into reverse engineering with tools like Cheat Engine, a free and open-source program originally designed for modifying single-player games. It offers a range of features, including a memory scanner, debuggers, and a disassembler, making it a Swiss Army knife for those looking to tinker with software. While Cheat Engine is often associated with game hacking, its tools are just as applicable to other areas of software analysis. For example, its memory scanner can be used to find critical variables in any running program, not just games. For those interested in static analysis, a dedicated disassembler is essential, and IDA Pro is the industry standard. However, IDA Pro's price tag is not for the faint of heart, which is why the open source community has provided alternatives like Ghidra, a free disassembler and decompiler developed by the NSA. Whether you're using IDA or Ghidra, these tools allow you to break down machine code into something resembling high-level source code, giving you a glimpse into how the software was originally written. When you use these tools, you're not just passively observing, you're actively rebuilding the program from the inside out. This process takes time, and even experts can't rush it. Every new piece of information you uncover adds to your understanding, slowly piecing together the software's design and logic. Debuggers play a crucial role in dynamic analysis. A debugger lets you pause a program at specific points, called breakpoints, and examine its state. Think of it as a freeze frame in a movie, except instead of watching a scene, you're looking at memory addresses, registers, and function calls. If you're serious about dynamic analysis, I recommend X64DBG, a free and open-source debugger that's feature-rich and user-friendly. Before we wrap up, let's quickly touch on a couple of other tools worth exploring. Cutter is a free open-source reverse engineering platform that competes with the likes of IDA and Ghidra. It's got a polished interface and plenty of customization options, but it's still relatively new on the scene. Over time, I expect it will continue to improve as more contributors join the project. Another specialized tool is Reclass.net, also free and open source. It's designed to help you visualize and reconstruct memory blocks, which can be incredibly useful when dealing with complex data structures. Once you've mapped out a memory block, Reclass.net will generate a perfectly formatted class for you to use in your C++ code, saving you the headache of doing it manually. And that's a wrap for today's dive into reverse engineering. Whether you're interested in game hacking, cybersecurity, or software development, the skills and tools we've discussed are invaluable across the hacking spectrum. I'll be exploring these topics in more depth in future videos, so stay tuned. If you've got feedback or suggestions, feel free to drop a comment. A big thanks to everyone for watching, and I'll see you in the next video. Cheers!